Hey, good morning, good afternoon, good evening, wherever you are in this beautiful world. We appreciate you spending time with us at Love My Tool. And we got a great session today with with Keith Bromley, who's our regular from Keysight Technologies Visibility Group. Uh, our host is Paul Alford of Advanced 7 in UK. Thanks for being here, Paul. And then we
Thanks.
have Mr. Bill Coon from Riverbed, who we all know about the steel product line. And so we're going to talk today about solutions, problems and solutions. So, Paul, thank you for being here and hand it over to you.
Thanks very much, Tim, and thanks for everyone who's watching. This is a particularly interesting subject for me because, as some of you know, Advanced 7 is an IT troubleshooting company, and we use a lot of network analysis, actually, to troubleshoot both network application and database issues and all sorts of things. So I love this subject, so I'm looking forward to hearing what we've got to say on it. And I'm going to hand over to Keith because Keith's going to kick us off with his point of view. Keith.
Yeah, hi everybody, and sorry I may appear a little dark on the screen there. I did that. I wanted everybody to get a better view of me, so I decided to go dark instead of light. Actually, I'm traveling and having a little lighting problem here, but hopefully it won't affect my audio anyway. So yeah, Keith Bromley here with Keysight, the world's leading test measurement and visibility solutions provider for everything from the physical layer to the application layer. And today we were going to talk about network troubleshooting, specifically about how you can use visibility to improve network troubleshooting, and then some tips and tactics that you can do to improve your troubleshooting experience. And so that's where Paul and Bill are really going to help us out here. Bill, you want to jump in and talk about Riverbed and so forth?
Sure. Yeah, for a lot of folks on the phone, I'm sure they've heard of Riverbed from an optimization perspective, but wanted to just give a brief intro to the sort of the new Riverbed, at least rather recently, because of all the changes in networks and applications and the infrastructure that you're supporting and those types of things. And that specifically, it boils down to three things that Riverbed does. It's cloud connectivity, managing and simplifying the management of LANs, WANs, and wireless, to have instant, secure, and excellent performance for cloud connectivity. Another discipline, the second of three, is the edge. Basically, being able to provide essentially performance as if it was local, but securing the storage of those applications that exist out at remote locations outside of the data center at the edge, and securing that connection, but also bringing that cloud storage or that data center storage back to the data center, but presenting it as if it was local. And then the third piece is obviously what I'm here for. Dear to my heart is digital experience management, where it ranges anything from the end user, where you just try to plug the visibility gaps between an end user and the application, potentially starting with end user, but also instrumenting in the network from a polling perspective, from a flow perspective, from a packet perspective, and then even inside the application environment. That's what Riverbed does as an integrated platform. And that's what I'm here to talk about a little bit with how we can leverage that kind of instrumentation to help troubleshoot problems that you're having managing the network.
Yeah, and troubleshooting's a big issue, as everybody knows. I mean, there was a 2016 EMA Megatrends report where they were talking that 36% of IT's personnel's daily efforts are spent on reactive troubleshooting efforts. That's a lot of time taken away from doing business enhancing, revenue enhancing activities that IT could be doing. And part of the problem is there's all these different tools for the network guys, the applications, the infrastructure. There's these different tools that they're using. You get a fragmented, incomplete view of what's happening on the network. And so one of the things you can do to improve that is to put a visibility architecture in, where basically you can put in taps and packet brokers and these visibility tools. It all starts with the tap, where you want to get the right kind of access to the data, and then with the packet broker, you can come in and filter data out, get rid of the extraneous data, filter out duplicate data, and really consolidate that that data, and then that's what you can send on to different tools like Riverbed and other tools that you may be using out there. But it really, by focusing and condensing that data, is where you can start to see what's happening. You get rid of all the extraneous data that doesn't matter, but it pops up and it looks like it could be interesting, but then it really isn't, and it just sort of takes you off on these whatever you want to call them.
Rabbit hole chases.
Yes, rabbit hole chases. Thank you.
Well, one of the problems that I find people out there do is they don't even know what's normal for their network. And if you don't have access and visibility, you're never going to know what's normal. So how in the heck are you going to determine that, something's wrong?
Purely from a practical point of view, from my side, one of the issues we face is that if you do some packet capture in a data center and then you need to reorganize the patching or the capture points, you're talking about sending someone to the data center, because so often they're co-hosted platform as a service type data centers means someone's got to go down there and actually repatch the thing, whereas having that ability to reconfigure without having to put through switch configuration changes and things, that's attractive. That's what I like about packet brokers and the whole matrix switching and packet broking type approach, is that remote operation.
Yeah, in fact, one of the great things is once you stick the tap in there and then the packet broker, a lot of times you don't really have to touch the network again, because when you look at the mean time to repair, part of your time is getting approval to go in and make changes. You've got to go to the change board, because if you go in and you touch the network, there's a chance you're going to bring it down, you're going to affect other things, you're going to break other things. But once you put that tap in, it's pretty much set and forget. And then you can feed your packet broker from that, and you can go make changes to the packet broker, because it's not going to affect the flow of data on the network. It's basically out of band at that point. It's the tap's in line, but the packet broker's out of band. And so we've actually had customers that once they put that combination in, they've reduced their mean time to repair by up to 80%. And we've actually had several of them do that, because again, a big chunk of that was these change board approvals. Then you had to wait for the maintenance window. And once the tap packet broker combination is in there, you're good to go right off. You can start feeding your tools. You can send data over to like Riverbed's Steel Central tool. You can feed all of these diagnostic tools at will. You can make changes. You can do filtering on the fly and really groom that, or not groom, but condense that data down to what you need it to be when you need it to be.
Yeah. So while we're on that subject, and just to bring Bill into the discussion, what I'm really interested in is, if you're taking a proactive approach, ideally you want long-term packet capture, ongoing 24/7. But doing that practically across all of the possible source points in your network, if you even just take the physical network, let alone what you've got virtually, you could be looking at capturing from literally hundreds and hundreds of capture points. So if you are going to continuously monitor with something like, excuse me if I get the product name wrong, Bill, but Cascade, that type of approach, the long-term capture, what's the strategy? Do you do it at the edge? Do you do it at the server interfaces? Do you do it at inter-switch links? What's the recommended strategy for that?
Right. Yeah. So along with the conversation so far, what I recommend to folks when I talk to them about visibility is you've got to start somewhere. A lot of folks say, hey, I've got this problem. Let's buy this tool that says it's going to solve this particular problem. Very tunnel vision and not thinking of big picture. And you think about it, if you take a network perspective, there's really three main types of ways of monitoring that network in the application. And that's, polling for the infrastructure devices, networks and servers, things like that. Broad reach, but not very deep. And then you've got flow technology. Cascade is the old name. We call it Net Profiler now, but certainly leveraging flow technology. Go ahead. Yeah. Certainly leveraging flow technology from a visibility perspective, it provides much more than packets, or not much more than SNMP, but it doesn't do what packets do, which is adds those performance details. And so what I tell people is, if you've got to start somewhere, start at least from an end user's perspective of performance. And that's at typically the WAN D mark, whether that's up in the cloud or whether that's in your data center. but at least get some visibility into how the performance from the front end perspective of multi-tiered applications are, how it's impacting that end user. And that's at least a start. And then you work your way back into the data center and start to discover all the different pieces, because I'll guarantee you, once you enable that visibility, you're going to start to see different things that you didn't even know were running on your network. And you typically will focus on a specific application or group of applications. So prioritize, because to do everything is almost impossible, especially in these large distributed hybrid networks. But focus on those mission critical applications, instrument them. Typically the passive approach of a tap, once you get it installed, is the least intrusive way of monitoring an application. And with packet analysis, not just capturing those packets, but also producing metadata to understand the performance, it's key to just not first, don't get ahead of yourself. Monitoring a specific thing is great, but first use it to discover what you do have, because you don't know what you need to monitor until you do that discovery. So that's what I tell a lot of people is at least get that access point in and out of that server area, and then work your way in towards mission critical applications to get the visibility between those application server components when it's not out on the network.
Probably go out a bit further than that though, Bill, wouldn't you? Go out to the remote office. If you've got a sort of star configuration style of business,
right? The more
you go out to the user office,
right? The more I tell people, anytime packets are available on the wire is a good place to grab them. Whether you grab them with agents like what we have agents that can actually sit on servers and users, or if you can instrument a packet capturing appliance fed through a packet broker, for example, that certainly is a luxury at a remote site, but certainly is a good one. And that's where you start to complement, this deep dive packet level visibility, typically in the data center, where you can afford to put these boxes, and then complement that with the extended reach of NetFlow and SNMP. And that's really the strategy behind Riverbed, is to bring that visibility into a single view so that you can extend that reach with technology that exists out there, but also complement with the performance details all the way into web transactions and SQL performance, those types of things, leveraging packets.
One thing that I tell people talk about, well, I spend 36% of my day troubleshooting. You know what? I think we should have people that spend 100% of their time knowing their patient, their network. You should never be reactive. You should always be responsive. And that comes with visibility. It comes with routine. As you were pointing out, learn about the facility you have. Learn about collecting logs or SNMP flows, or, metadata is a great way to look at how the world is looking at what you're doing, especially if you get metadata from your applications that are touching everyday customers. And one thing you don't want to have is a customer not stay on your website because they can't get anything done because all the applications and all the network stuff is working, but the application is a failure. So I always, when I coach people, I say, get someone or some people and have a team that watch your network 24 hours a day, because if you don't know what it's doing when it's good, you're never going to know what's wrong with it when it's broke.
I think the point you made about using the metadata and the flow information, whether it's flow or Riverbed microflow type stuff coming out of NetSharks and things, it's only following those trends that you're going to be able to do any real-time monitoring. I mean, obviously you can't real-time monitor very effectively looking at packets because there's just too many of them. So I know you can get it summarized and maybe get exception reports, but the net profiler approach is that Green River thing, isn't it, Bill, where it follows along and produces upper and lower limits on certain metrics.
Right, actually learning normal behavior and then triggering alarms dynamically and automatically based on deviant behavior. So it builds this, what we call the river graph, which is basically a bunch of statistics that say, hey, at this particular time of day and day of week, what's normal utilization or performance or retransmissions and things like that, and let me know automatically whether it deviates based on what the normal is for that time of day. So it's actually pretty neat. And, you bring up a good point. I just wanted to point out too is, you could argue that, 30% or whatever the number, I'll just use this as an easy example. 30% of the time, you're probably going to solve a lot of networking issues with SNMP, right? Just as, everybody's got it. 30% of the time, it may be flow, and especially flow that's enhanced with some performance metrics from packet capturing, like that profiler is. And then the other 30%, you'd actually leverage that metadata. Whenever you need that, you got to get down to that detail. And then lastly, there's always this sort of 10%. I call it the necessary evil. But it is one of these things where we've got to get down into the packet sometimes, because you have to get to that detail. And so that's where it's really important as you're trying to figure out how to get visibility, how to troubleshoot problems proactively, take advantage of existing technology, as well as this packet technology has been around for a long time. But think about when you're solving that problem, how do you take advantage of those packets? And what I tell people is usually it's got to do at least three things. It's got to feed a bigger picture, something like a flow analyzer that sees more than just in the data center. It's got to do the metadata. So don't make me have to be a Wireshark genius to be able to figure out what's the performance is. But then also capture packets. So when you do need that 10% or whatever at the time, being able to drill down into those packets to be able to solve those issues that can't be solved by metadata or flow data or poll data.
And that's when you hit Hansang Bay on speed dial.
Yeah, I wish. Even Gerald Combs, right? He's a Riverbed employee since we're the corporate sponsor. But lots of packet capturing expertise. But the idea is, don't get you down to that level. And we've got software that works with packets that we call Transaction Analyzer. It actually analyzes packets sort of, more detail and specific to a single transaction. But there's all sorts of ways to leverage those packets. The hard part is sometimes just getting to them. And that's where, packet brokers come in. Whether you're trying to tap into this virtual world, into the cloud, whether you're tapping into the traditional data center, that's usually the harder part. But once you can get an efficient feed into a packet capturing appliance like our app response, that's where things start to get a little bit easier in identifying how to troubleshoot problems more proactively than always reactively.
Yeah, I mean, it's about knowledge a lot of the times. I had a guy one time want to tell me he wanted 90% efficiency out of his network. And I said, well, okay, that's a great goal, but I don't know if that's going to happen. So I said, just tell me how many bad, what's your percentage of bad packets? And he says, I have no clue. I said, well, you don't know what your network's doing. And actually, he had some major plant issues. He was the guy I told you, Paul, that decided to put 1,000-foot cables on almost all of his internal network. This guy he had at least 40-45% physical layer problems. And he didn't know it because he didn't want to look at that. He didn't want total visibility. He wanted to look through a span port and not, and a span port's good for some things, but if you got to know what's going on. That's like having two patients and you take the pulse of one and assume that the other patient has the same pulse. Not
well,
a
anyway,
good way.
Picking up on what Bill just said is a great segue actually into what I was going to ask Keith, which is a similar question to the one I asked Bill, which is, where'd you put your taps? I mean, if you're in a data center and you've say got I don't know, 2,500 switch ports, where do you put the taps? Do your customers commonly tap certain places in their network?
Yeah. Typically, they're tapping at the ingress, egress, and then they're tapping when it comes into the data center. Sometimes they're doing within the data center as well, but you got to be cautious too. You don't want to. The more taps you put in, the more data points you collect, the more chance you've got for a lot of duplicate data as well. So then you've got to have the deduplication. But if you're finding out you've got a massive amount of duplication, then you're spending a lot of time and resources and energy to deduplicate all the time. So for us, our customers, it can be all over the board. Some will even put in. With the tap, it's set and forget. But some will actually go in, I've heard, especially with the financial customers, and they'll put in temporary taps because they want to go and they want to track down through different hops where latency's coming from, or is it reaching to like wouldn't say the desktop, but out to the end lineup there where the desktops are. What's the latency going in? Because for those guys, you know, like a millisecond can be hundreds or thousands or maybe even $1 million lost if they miss a trade based upon you know, a time lag.
Or as a network engineer told me in an investment bank, it could actually save the bank a lot of money by preventing the trade. But there you go. That's a very cynical view of traders.
Yeah.
There's always two sides of a coin, right?
Yeah. So I hear what you say, and I think this is the thing that I think it's quite tricky figuring out where you're going to put your taps. And I guess what you would do, and I can't remember if it was Bill or you said about critical systems, you know, if you take a bank, for example, certainly in the UK, typically a UK bank will have 12 systems that have to be operating for them to be legally running as a bank. So there are 12 core systems that must be up and running. And I guess those are the sorts of systems. And in an e-commerce site, obviously the actual site, rather than the back-end system, reporting systems, the site's got to be up all the time. So another prime candidate to stick taps all over the place, I guess.
I think what you do is you call a professional like Bill or Keith or Paul and say, hey, I got a network. Here's what it looks like, I think, because it probably is different than it was 15 minutes ago. Mm-hmm. And help me build a step profile of visibility. You can't monitor everything. You can't drink from a fire hose. An average packet takes 2 to 3 minutes just to overview. If you want to look at a packet, we did many studies at Network General back in the old days. And so you get a professional in and say, hey, listen, I want a pro, someone that, not a salesman. You don't want someone that just wants to put them in the bathroom and everywhere else. You get a pro in like Paul or like you, Bill, or like you, Keith, and say, hey, where do I start? And it is a process. It's not something you just throw and see if it sticks against the wall.
Yeah, and then to a point you had mentioned earlier, Tim, too, part of it's also the process. You know, some of these people, hey, we've put in 1,000-foot runs, we've done this, but you know, as things move along, we've got different processes. There's you can put the visibility architecture in place with the tap, the packet broker. You've got all of these cool tools now that you can go and insert in there to make diagnostics faster. And then you've got these dashboards and portals that you can put in there to do a lot of the monitoring for you for the parameters or parameters inbound, out of bound, and really speed up the process. You know, things are changing in my opinion. You know, for troubleshooting, you can't do what you did 5-10 years ago. Things are changing. You've got to move with it, or you're going to be to have too many time delays, be stuck in the past and not do what you need to get done. You can't do what you did a year ago. I'm sorry. There you go.
Yeah, just to make that sort of emphasize that point, things aren't getting any simpler, unfortunately. I mean, we're trying to simplify management of network connections and things like that, but under the covers, it's getting more and more complicated. And so that's where, you know, I have this conversation almost daily with our customers of where do I tap, you know, and sort of like I said earlier, you know, it depends on priority. Is it a specific application? Are you concerned about if the application is slow, which piece of the application? If it is, then you got to move it in towards that distribution layer, even the access layer. And that's where packet brokers really do help tools like ours that process packets, because they can filter on mission critical systems without over flooding a packet capture and analysis device. And I tell people this all the time. Don't be, I guess, don't avoid the problem because it's just too big. And you say, well, there's no way we can do all of our traffic. Remember, these packet brokers, as well as packet capturing appliances on a more limited scale, can filter these big, heavy streams of packets down to what you really care about, so that you can at least start to monitor those mission critical apps.
All right.
Yep. And then, one more thing to keep in mind too. At least in my mind, we've been talking about a lot of physical networks with the cables and stuff, but you know, for the cloud networks and for the virtual data centers and stuff, troubleshooting and how you're going to go about it, what tools you need, what capabilities you need, it's something you need to plan out there as well. It's not, you know, I tend to come, I guess, maybe from the infrastructure side, because that's where I quote grew up. But even in the virtualized worlds, troubleshooting, getting actual packet data in the cloud for application performance monitoring, for troubleshooting, you need that packet data, and you need to be able to get to that data to send it to your tools.
Right.
Yeah. Yeah.
And you can drown pretty quick. By the way, you know, we got Wireshark. Everybody knows about Ethereum and then Wireshark with Gerald. But don't forget, we got products like Transom, Workbench. We got a ton of really good products that have been designed to build a foundation. But to feed that, you got to have access. And you got to start somewhere, or it crashes very quickly.
With the, we're coming up to time, but just one question I wanted to understand. What impact will SDN and the rapid, sort of very flexible provisioning of network services, what impact will that have on the tool sets that we have available to us right now? Bill, what's that going to do for us?
Yeah, certainly. Obviously, that complicates matters from encapsulation and understanding the SD-WAN world, or even inside the data center, this virtual world. And so you've got to be able to, de-encapsulate those packets so that you can process them as normal. And that's where we can leverage, the packet brokers for that type of information, as well as on a smaller scale. It's always one of those things on a smaller scale, we can do some of that natively, but it certainly helps to take all the different, and some of this hardware now, there's multiple tap points. It's getting very, very difficult. And on our packet capturing appliances, on anybody's, it's expensive to try to accommodate that all. And that's where, as you start to, get that visibility at all these different tap points where you may need it, that's where you take advantage of the packet brokers like Ixia, where it can bring it all in an efficient stream into our packet capturing appliances, rather than trying to feed us all from the actual devices themselves.
Okay, and I guess that fits with your view of the world, Keith. What do you think about this?
I was going to say, hopefully, to answer your question, hopefully, very little impact on the tools. If you put in the right packet broker, so you're going to get a lot of traffic for like some of the ACI architecture stuff with the BiDi taps. If you're running 40 or more gigabits per second, you're going to get a lot of duplicate packets created. But you put the packet broker in there and you do the dedupe at wire speed. Okay, so now you've got more data coming to the tool, which you need to have enough tools to handle the data. But from getting rid of the dedupe problem, we've taken care of that with the packet broker. Also, with like header stripping, you can do get rid of VXLAN headers and stuff like that with the packet broker. So now you've gotten back to just delivering the right data to the right tool at the right time. So
just make sure you don't have duplicate packets.
Yes.
Okay. Don't hurt yourself saying, "Oh, I'll hide it from my visibility," and then find out that, "Oh, I do have multiple paths. Uh-oh, no wonder I have problems."
Yes.
Okay. All right. So I'd like to just wrap up here and sort out the takeaways here. So as I understand it, the takeaways really are, I liked Bill's idea of this top downwards type of approach to, starting with some high level flow information, moving down into more and more granular detail as you need. And as he said, knocking out the first 30% of problems, then another 30% and so on. So that sounds good. For using packet brokers and taps to feed data, certainly I love the flexibility of it. I love the remote operation capability of it. So that sounds like a great way to go. And to what Tim said, try and get to know your network. And with tools like NetProfiler or similar tools, you can begin to learn what's normal and what's not. Okay. I don't know if anybody's got anything to add to that, but that sounds pretty good to me.
Sounds good.
I think it's great. I think people should engage professionals that have been out there shoveling it. They know what to dig and what not to dig.
Okay. All right, great. Well, my final word is, Denny, you better get back here quick because, we need your help.
You don't want to know what he sent me the other day.
Okay. Anyway, thanks very much, guys, and we'll draw it to a close there, and we'll see you next time on LMTV.
Everybody be blessed. Take care. And Bill, let's write some articles.
All right. Sounds great.
Okay.